Okay. So, Gay-Lussac's law. Gay-Lussac made, thank you for reminding me of this too, by the way, pressure and temperature. When you have pressure over temperature and pressure over temperature, they are directly proportional. So when one goes up, the other goes up. One goes down, the other goes down. It's when they're side by side that they're inversely proportional. When one goes up, one goes down. Okay? So think about it. The pressure cookers, basically when pressure is exerted by a gas, it's directly related to the temperature of Kelvin. So if you have a pressure cooker, you can get higher temperatures because you're pressurizing it. That's why we cook things like fried chicken in pressure cookers, because if you try to cook fried chicken in a pan, if you don't do it on really, really, really low, then you got a lot of bloody chicken in there. It's just gross. But if you use a pressure cooker, it increases the temperature so much it cooks it throughout, which is kind of what you want with chicken.
Crock pot, is it?
No, a crock pot is not. A crock pot's a slow cooker. It just cooks really slow all day for you, so it doesn't burn or anything. So you can cook it for like 8 hours. But the Instapot, I think, is becoming more like a pressure cooker. I don't know what an Instapot really is. I know what it is. I've seen it, but I don't know if it's a pressure cooker or not. It cooks. Is it? It cooks really fast, right? But pressure cookers are good because they just increase the heat so much, and because due to pressure. So it's like when you just add heat to like a can of some sort, it just pressure gets great and usually burst. Do I need to go through this problem with you? Can you plug and chug and solve it?
Yeah.
Okay, I think so. So then there's Avogadro's law. Avogadro's law. Avogadro, the volume of a gas is directly related to the number of moles of a gas. So this shows a relationship between volume and moles, which makes sense. It's like if you ever put too much air into a balloon, it pops. You know, or if you put too much air into a tire, you know, as you pop air into it, it gets bigger and bigger and bigger. When you put more particles into something, it takes up more volume. It just makes sense. Now, the temperature and pressure are constant here. So we're not changing any temperature, we're not changing pressure. We're adding more particles. Does that make sense? Yes?
Yeah.
Okay. And we could go through it. That's the formula for it. I'm not going to go through the problem. You can do that as well. Are we good so far? Okay. Let's see. Now, I'm going to go over this with you. The combined gas law. The combined gas law is all of these gas laws put together. So, we have one big law that encompasses all of these. Because even though you say you have this relationship between volume and number of moles, pressure is going to change. The pressure could change while you're putting all that stuff into that small amount of volume. You know, temperature could change. Everything's changing constantly. So you have to look at that as a whole. Okay? So the combined gas law is Boyle's law. P1 V1 equals P2 V2. There's Boyle's. Let's add Charles's law in. Charles is volume over temperature. So there is Charles's law. Gay-Lussac's is pressure over temperature. Here's Gay-Lussac's law. And then we put an N in here to get Avogadro's law of volume and moles. So basically, we just took all the laws and put them into one big equation. And you can always, even if you don't remember, you have this on the back of your periodic table, but they'll always say temperature and number of moles are constant. If temperature and number of moles are constant, you got Boyle's law, right? So you can memorize one equation and then just look at what's constant. Yeah, Lynn?
I just had a question, because you put N1 and T1 on the bottom, and I wasn't sure if it was supposed to be N2.
It should be. Over here? Yeah. Yeah. That's when I get talking, I forget. Thank you. Does this make sense? Yes or no? So if we have a problem that says something like this, this board needs to be cleaned. Ugh. Okay, so if we say, okay, we have a substance with a volume of 0.75 liters at a pressure, do it again, pressure of 0.9 atmospheres and a temperature of 279 Kelvin, and we've got 0.12 moles of sodium chloride. Okay, so we say, okay, then what is the new volume if we have a pressure of 4.1 atms? Wow, went up. Temperature is changed to 302 Kelvin, and our number of moles stays the same. So at this point we just put our numbers in. So P1, 0.9 atmospheres times 0.75 liters over 279 Kelvin. Do I have to put my moles in there? No, because they stayed constant, didn't they? They just stayed constant, so we just leave them alone. And then equals 4.1 x over 302. Now how do I solve for that? How do I solve for x? Okay, I cross multiply, but what I would do first is I'd probably multiply these two first, right? And then multiply by that, right? So that is kind of cross multiplying, but it's a little more. So we have, oh, this one's gone. Oh, so we have 0.9 times 0.75 times 302 gives me 203.85, 203.85 equals 4.1 times 279, 1143.90x. Did you guys get that? Divide both sides by 1143.90, 1143.90. So 203.85 divided by 43.90, 0.18. So the new volume is 0.18 liters. Does that make sense? It's pretty straightforward, isn't it? Yeah? Thing is, knowing this stuff, writing this out. And please remember, STP, standard temperature and pressure. Standard temperature is always 273 Kelvin. Standard pressure is depending on what you're using. If it's atmospheres, it's 1. If it's kilopascals, it's 101.3. If it's torr, it's 760. If it's PSIs, it's 14.7. It's all those on the back of your periodic table. Those are all STPs, or SPs, unit of temperature. Does that make sense? Okay, so